The James Webb Space Telescope, the powerful observatory that often views galaxies billions of miles away, recently peered at a much closer cosmic object, the gas giant Saturn. With the addition of Saturn, the James Webb Space Telescope has finally captured all four of our solar system's giant worlds. JWST's observations of the ringed planet, taken on June 25, 2023, have been cleaned up and processed, giving us a spectacular view of Saturn's glorious rings, shining golden in the darkness. By contrast, the disk of Saturn is quite dark in the new image, lacking its characteristic bands of cloud, appearing a relatively featureless dim brown. This is because of the wavelengths in which JWST sees the universe, near and mid-infrared. These wavelengths of light are usually invisible to the naked human eye, but they can reveal a lot. For example, thermal emission, associated with heat, is dominated by infrared wavelengths. When you're trying to learn about what's going on inside a planet wrapped in thick, opaque clouds, studying its temperature is a valuable way to go about it. Some elements and chemical processes emit infrared light, too. So seeing the planets of the solar system and wavelengths outside the narrow range admitted by our vision can tell us a lot more about what they have going on. Saturn. As we saw last week, when we clapped eyes on the raw JWST Saturn images, the observations involved filters that dimmed the light of the planet, while allowing light from the rings and moons to shine brightly. This is so a team led by planetary scientist Lee Fletcher of the University of Leicester in the UK can study the rings and moons of Saturn in more detail. They hope to identify new ring structures and, potentially, even new moons orbiting the gas giant. The image above shows three of Saturn's moons, Dione, Enceladus, and Tethys, to the left of the planet. Although dim, the disk of the planet also reveals information about Saturn's seasonal changes. The northern hemisphere is reaching the end of its 7-year summer, but the polar region is dark. An unknown aerosol process could be responsible. Meanwhile, the atmosphere around the edges of the disk appears bright, which could be the result of methane fluorescence, or the glow of trihydrogen, or both. Further analysis could tell us which. Jupiter. Jupiter was the first of the giant planets to get the JWST treatment, with images dropping in August of last year, and boy howdy were they stunning. The spectacular detail seen in the planet's turbulent clouds and storms was perhaps not entirely surprising, but we also got treated to some rarely seen features, the permanent aurorae that shimmer at Jupiter's poles, invisible in optical wavelengths, and Jupiter's tenuous rings. We also saw two of the planet's smaller, lesser-known moons, Amalthea and Adrustia, with fuzzy blobs of distant galaxies in the background. This one image sums up the science of our Jupiter system program, which studies the dynamics and chemistry of Jupiter itself, its rings, and its satellite system, said astronomer Thierry Fauchet of Paris Observatory in France, who co-led the observations. Neptune. Observations of Neptune arrived in the latter half of September 2022. Because Neptune is so very far away, it tends to get a little neglected. You're probably used to seeing, if anything, the images taken by Voyager 2 when it flew past in 1989. JWST's observations gave us, for the first time in more than 30 years, a new look at the ice giant's dainty rings, and the first ever in infrared. It also revealed 7 of Neptune's 14 known moons, and bright spots in its atmosphere. Most of those are storm activity, but if you look closely, you'll see a bright band circling the planet's equator. This had never been seen before and could be, scientists say, a signature of Neptune's global atmospheric circulation. Uranus. Uranus is also pretty far away, but it's also a huge weirdo. Although very similar to Neptune, the two planets are slightly different hues, which is something of a mystery, and Uranus is also tipped sideways, which is challenging to explain too. JWST's observations, released in April 2023, aren't solving these conundrums, but they have revealed 11 of the 13 structures of the incredible Uranian ring system and an unexplained atmospheric brightening over the planet's polar cap. JWST has a lot to say about the early universe, but it's opening up space science close to home, too. As its first year of operations comes to an end, we can't help but speculate what new wonders will be to come in the years ahead.